different wavelength is associated with only that kind of laser. Okay. So if you're talking about urban yak, it's always 2940 nanometers and nothing else. Nothing else. Okay. They're equal to each other. Okay. So water laser is 2780. And these two lasers, urban yak and urban chromium YSGG, is what we call urban family lasers. They are the only laser in the world that works on hard tissue. Nothing else works on hard tissue. So laser actually started with Einstein's theory on atoms and slowly developed into where we are today. And urban yak laser is first treated was in 1987. Along this, so we can, I want you to point out right here, you can see CO2 laser was developed in 64. And of course, it's heavily used in medical field, also in dental. But I'll show you, is it a good laser for dentistry or not? So, laser is an emission, it's also a light. It is not visible. We can only see from here to here, the rainbow color. So below it is ultraviolet, or ultraviolet. Up there is infrared. Laser is always in the infrared area. So let's talk about light to understand what laser is. Our normal light, daylight, is actually a combination of all the different colors. So it's visible, this area is the visible area, and it's a combination of all sorts of different colors. So for laser, it has three main characters. Number one, it's one single wavelength. It's not a combination of so many different wavelengths together. It's only one. It's in the infrared section. Second one is all laser beams are common, means it all move towards one direction. It does not scatter. It does not spread out unless you design it to do that. The third characteristic is it's coherent. Means they always stack up. Because they're all the same wavelength, they stack up together and go towards the same direction. They don't, one goes here, one goes there. So when a light, a beam of light hits an object, three things happen. Number one is reflection. Number two is scatter. Number three is absorption. Okay. We, as clinicians, you have to watch out for reflection into your eyes. It's the absorption that helps you work. The scatter is what you want to watch out for damage to the patient. Okay. These three things means different aspects when you are working in medical. Now, these are all the lasers that you do see in dental field with its associated wavelength. Diode is funny. Diode laser actually covers from 810 to all the way to 980 nanometers. That's the only laser that has a range. Okay? This is a diode laser. This laser pointer is a diode laser. So diode laser is the only one that has multiple wavelengths. Okay. I marked urban yak and diode in red because that's what we're going to talk about the most. And that's what will help you the most in your daily work, even though we have a lot more others. Okay, so we have erbium family and diode family. That's what we're going to talk about. Erbium family is
a water-seeking laser. It seeks water molecules in tissues. Okay? The way it works is, the way it cuts is by letting the water molecules absorb energy and it evaporates. At the moment it evaporates, it's kind of like a mini molecular explosion. And if you have a lot of those, then you're cutting. That's how it cuts. Diode laser works as it seeks for dark pigments. So in body, dark pigments are normal pigments or blood, considered dark color. So it's like wearing white shirt or black shirt, go out to the sun. Which one gets hot faster? It's the black one. So it works in the same way. But in reality, when you're handling a diode laser, it works very, very similar to electrosurgery. Okay. Now, earlier we talked about urban yak laser works by looking at water molecules. So what this graph means, every time you talk about laser, you always see this graph. Some people get sick of looking at it. This line is water molecule at different wavelengths, the ability to absorb energy from laser beam. So this arrow means urban yak. This red line on the side is urban chromium wax water rays. By physics, okay, not any trick or any proclaim that any company want to tell you. By physics, water laser is less efficient than urban yak. How much? By 55%. Okay. It means if you have 100 watts of water laser and 100 watts of urban yak shining on same two equal amount of water, the urban yak has 55% more energy in it compared to water laser, which means water laser cuts slower. Okay, but we're at the same amount of energy, right? 100 watts. Where does that energy go? It accumulates in tissues as heat and damages the tissue. That's where the scattering goes, what we talked about earlier. So once again, you see water as a blue line, and the red line is hemoglobin, how well it absorbs different wavelengths. So when it gets to where urban yak is, it actually doesn't work at all. But if you look at 900, that's a diode laser. If you look at water absorption, it works really poorly. Means if you stick a diode laser into a cup of water, you can sit there and step on the pedal for a year. Nothing happens. Nothing. Okay? So diode laser does not work in a very wet environment, but it works well in an environment where there's a lot of dark pigments. Normally, laser works in pulses. Even if it tells you it's a continuous wave, CW, you will see this initial response. It still works in pulse. Why do we work in pulse? Because this time in between pulses is very critical. We need tissue to cool down. If you don't have these, you get charred. Basically, you burn the tissue. Instead of time, sometimes we use water for cooling as well. So you have both. Now, sometimes certain brains will even do this. Remember, last graph is one big clump right here. Means open, close, open, close. Okay. So it's on, off, on, off. Now, sometimes we raise the energy power output, but put in more pulses in between to create faster cut, but less irritation, less heat buildup, so let's try.